also hope to be a bit more brief this time. I think I will make back the time I went over before. So I will talk about reusable data collectors in the Open Data Hub. So this is what our architecture used to look like. Maybe some of you have attended some presentation of us, of our new architecture that we've been implementing. Before it used to look like this, so it's quite naive, I would say. You have a lot of data providers, which are the clouds on the left. For example, the A22, a car sharing provider, could be some parking station somewhere. And then we have a lot of microservices called data collectors, which usually they are just like a small container that runs a cron job and every once in a while makes a REST request, or maybe it's a SOAP call, or maybe it could also be a server that gets some push message. All these data collectors are usually implementation specific. So okay, what I forgot to tell is, so they make the REST request and then they translate it into our Open Data Hub format, I would say. So we have our own schema, which data has to be ingested in the Open Data Hub, and the data collectors do both of the things. So they get the data, then they transform it they normalize it, in effect, and then they put it into the Open Data Hub. And this is very specific for each implementation. So it could be that we have 5 providers of parking data. Each one usually has their own kind of JSON structure. So we have to implement 5 different data collectors. And so you repeat a lot of stuff. And this used to be the way we were doing it. A few years ago, we started to develop a new architecture, and now we are quite far along in the development. I think, at least in testing, I think around half of the data collectors maybe are now on the new architecture, and new ones are only written on the new architecture. So I think, yeah, piece by piece we will migrate them to the new one. So this is what the new one looks like. So the important part is that we split the collecting part from the transforming part. So now we have a small program in the front that just gets some data. Like, for example, you see there, the first one is called a REST poller. It polls REST. So it just runs on a cron job configurably, and it just does a GET request to somewhere and gets some data, maybe a JSON. And that's all it does. Then it puts it on a message queue, in this case, a RabbitMQ. The data gets stored into a raw data storage. And then afterwards, there is a transformer, a specific transformer. For example, the REST poller can be reused for all 5 parking providers. But since the format of every parking provider is different, we have 5 different transformers. So in effect, you have a transformer for each data format. The transformer gets the message that the new datum has been requested, transforms it into the Open Data Hub specific format, and puts it into the Open Data Hub. So what were we trying to achieve with this? One thing is the integration time. So the time to integrate new data providers can potentially decrease a lot. Because if you have a REST endpoint that we can poll, I just have to configure the REST poller with a different URL, with a different cron schedule, and it just runs. I don't have to do anything, and I can collect data right now. It can be like a 5-minute job to set it up. Also, it gives us a unified architecture, so all our data collectors have the same structure. They use a raw storage in between, so we have all the raw data in not transformed format. So if later down the line we want to add something to the transformation pipeline, or there was some bug that we fixed, we can re-elaborate all the data we have, so because we have it in the original raw format. We can also minimize data loss. These data collectors are very simple. They tend to not break. Usually transformation breaks because someone changes the data format without telling you. So in this case, then the transformer gives you some error, and you say, oh, okay, I fixed the transformer, and run all the data again, all the raw data, and there it is, no data loss. And before, we used to actually have holes in the data. I'm sure everyone who used to interact with us, it's not always our fault, but sometimes it was also our fault. And then you don't have the data. You don't get it back because it's historical data, and it's lost. It also gives us bug resilience. So if you have a bug in a transformer, as I said, the data can just be re-imported again with the fixed version. That's a huge thing. And another thing is you can do the implementation and debugging work, the initial implementation, with the raw data already. So I set it up, I get your data, and then I can develop using the real data that you have. So the advantages for the data providers then are they have a very fast onboarding. They can have very low cost onboarding, because if they are using a format that we already have a data collector for, then we can just set it up. You don't have to develop it from scratch. We can also keep all the data from the history of implementation. So if I start to collect data today, I can work on the transformer for the next 6 months. Then in 6 months, when I have the transformer ready, I still have all the data from the 6 months that passed during that time. So, and you can add additional features to existing history. So you can say, okay, I collected raw data for 3 years, but now actually I want to also include this field into the Open Data Hub. And I can say, okay, I can re-elaborate the data. I have the raw data. I can add it there. Now I get to a use case where this actually happened. So this is not some dream. We already have this implemented, and it also works. So this use case, we had 2 new parking providers. So one was Star, and another one was the municipality of Bolzano. Both of them had different technical providers and formats, but they both had JSONs that they could push to us. And so we had implemented a REST push API. So how it works is we have this API here that is completely configurable via the authorization component. So we use Keycloak, which is a no-auth implementation. And just by giving the providers access to different URLs, we just send them a credential pair, send them a URL they can push data to, and then they started pushing JSONs. So the setup was completely frictionless. We just said, okay, this is the endpoint, push the data there. And then afterwards, in a second moment, we could implement the transformer, look at the actual data, or even wait until actual data arrived, because sometimes it didn't arrive immediately. This is just how you set it up in Keycloak. You just define 2 URLs, and you give them permission for the 2 different credentials, obviously, and that's it. So you don't even have to touch the application. We just did it on the configuration side. This is how the push API looks. We even did a Swagger, which is a bit ridiculous because there's a single URL. Just push, and then you get a provider and dataset ID from us, and you just push your whatever there. We don't actually care what format it is. You can just throw it in, and then we'll deal with it afterwards. So what was nice here was it was instantaneous onboarding. So Roberto opened an issue, said, "Oh, we have a new parking provider. We have to implement them." We just communicated URL, and one of them, I think, initially started pushing the data. So it was completely frictionless. Yeah, I think it was a very nice use case to prove that this architecture that we chose actually worked and provided to be useful in this case. So it was very nice for us to see it validated. And so this is not the only one we have. So one objective of this talk here is to tell you we have quite a few now of these reusable data collectors. So here you can see this is our repository, or this is an excerpt from our repository. For example, we have a e-charging OCPI. So OCPI is a e-charging standard that is now, like it's an international standard that e-charging providers use. So theoretically, any e-charging provider could become a data provider of the Open Data Hub, and we can at least set up the connection very fast. We have Google Spreadsheets, for example. If you have some static data in a Google Spreadsheet, we can just switch it on, and it's immediately loaded. Then we have the LoRaWAN. So we have the NOI has a, I think, public LoRaWAN. Maybe you can talk to Stefano about it. We have some pilot project with some room sensors ongoing where we use the LoRaWAN. So if you are using the NOI LoRaWAN as well, we can also integrate you quickly. We have an MQTT client if you have a MQTT server. We have REST polling, obviously. So if you have your data on some server somewhere accessible via REST, even if it has OAuth or some authentication, we just need the URL and set it up and can start polling it. And then there's also the push API that I explained to you in the use case scenario where you can push. So if you have client programs that have data and you want to be a data provider of the Open Data Hub, we can give you a URL, we can give you an OAuth credential pair, and you can just shoot us the data, and then we figure out afterwards how we are going to transform it. And then we also have a S3 poller, so if you have a S3 bucket, maybe more of a niche use case, we can also pull data from that. And we also hope to add a lot of these data collectors in the future. So actually what we've seen is, we thought, okay, usually things are not that generic, you will just have a lot of these data collectors, but no, it turns out like 50% of the cases can be handled by REST pollers, some probably by the REST push, and they are actually reusable, so this system works. So if you are interested in becoming a data provider of the Open Data Hub, especially if you have data in an already supported, I say format, but it's probably more about the protocol, or if you are using a format that you think that could be interesting for us to implement. So if you say, okay, I'm using this standard, it's used industry-wide, I want to be a data provider, then maybe we can find a way to implement this standard. And also, if you are a technical provider, for example, we heard of Skidata today a lot. So if you are a provider to potential Open Data Hub customers, or Open Data Hub providers, you can get in touch with us, and we can implement a data collector that integrates your system so that your clients, your customers, can be integrated with the data with the Open Data Hub very quickly and easily. So yeah, these are some URLs. So if you want to get in contact, if you're interested, contact help@opendatahub.com. Our customer care team will be happy to answer you. This is the repository of all the data collectors in the new architecture that we currently have, if you want to take a look at it. And then I've also linked the infrastructure repository where you can find the core system, Terraform stuff, and so on. Also of the stuff that Matteo told you about. Yeah, that's it. Thank you very much.
Thank you, Clemens. We have 3 minutes, so there is space for a question or if someone wants to share something.
Hello, hello. Okay. I think you saw it coming that I was going to ask you a question, but okay. When you mean the data collectors, they are reusable, do you mean the source code is reusable or the instance is reusable, like the runtime instance?
So how we currently do it, actually it's the container that's reusable. But yeah, we tend to launch a instance for every data provider, except in the case of the push API, it's the actual one instance that's being reused because it's completely configurable. But I don't think either way is the right or wrong way. It's just how we can handle things currently. I think for stability, you can always value if it makes sense to do one or the other. But then you could also write the program in a way that it's error resilient. I don't think it makes a lot of a difference. We just do it in that way because then we have one built CI/CD that builds the Docker image, and then we just have different config files in the end. We just have some different environment variables. For example, the REST poller has, I don't know how many deployments, or now we have the multi-REST poller. Yeah, like 5 or 6 deployments, which are just different configs, but always the same container.
Okay. Thank you, Clemens. The time is over. So it's now time for